All right, we're getting ready to learn how to solve literal equations. Solving literal equations for a specified variable by using inverse operations. So in our first thing, we're going to just kind of review solving a one variable equation. And basically this equation has already been simplified all the way as far as it can be simplified. So instead of using PEMDAS, which that's what you use when you're simplifying, we're going to use the opposite of PEMDAS, SADMAP, which starts with addition and subtraction first, and then goes to multiplication and division, and then goes to exponents and et cetera, et cetera. And so basically, we're going to deal with what needs to be added or subtracted away from it to isolate x. Well, that's the 2, minus 2. So we're going to do the opposite of minus 2, which is adding 2 to both sides. Okay? That looks like this. The negative 2 and positive 2 cancel each other. And on the right side, you get 10. So you end up with 5x equals 10. And now we're moving from addition to subtraction to multiplication or division. Well, which one are we going to do to get rid of the 5? Well, the 5 is multiplying by the x. That's what it looks like whenever multiplication looks like that whenever, we want to say multiplication in algebra. We just put the number right next to the variable or the variable right next to the variable. Anytime you see something right next to each other, that means multiplication, okay? Without anything in between it. All right, so in order to split those things up or get rid of it, you have to divide. So we're going to divide by 5. The 5s cancel each other out. And 10 divided by 5, of course, is 2. All right, so hopefully that was just an easy little review for you. Remember, we use PEMDAS when we're trying to simplify an expression. And then we use SADMAP when we're trying to solve. We go in the reverse order. All right, so solving literal equations. Now we got a little bit different situation because there's going to be more than one variable. So we have to identify the variable for which we're solving so we can isolate it. Then we need to use inverse operations to isolate that variable. Combining like terms is usually not possible because, like we said, there's more. All the variables in the equation are going to be different. And very rarely are they going to have you combining like terms, but they might. So just keep a lookout for it. And adding grouping symbols. Sometimes we need to add parentheses just so we can make sure that the order of operations does not change. And we'll see an example of that in a second. Okay, so our first example is m plus a equals p, and they want us to solve for m. Okay, and so this is relatively simple. The only thing that's happening to m is that plus a. The p is on the other side of the equal sign, so we really don't have to worry about it so much. And so in order to undo the addition that's going on with the m, we have to do the opposite of addition, which is subtraction. So we're going to subtract a from both sides. Looks like this. The a's cancel. And since p and a are not like terms, we can't combine them. So we end up writing them side by side like so. That was a one-step equation. It only took one thing to get to the answer. Okay, one operation to get to the answer, and it's solved. Okay, that's solving a literal equation. Great job. Next example gets a little bit more complicated. So now we're dealing with volume equals length times width times height. That's what those dots mean, multiplication. And so we need to get rid of everything that is not W. So we want to isolate W. So just put a box around it. That's what we're going for. So that just leaves the L and the W to get rid of, and we said that length and height is multiplying the W. So we're going to have to do the opposite of multiplication, which is dividing. So we'll start with the L, and then the L's will cancel, but we'll go on to the H at the same time. We don't have to do this in two separate lines. We can just put the L and the H on the bottom The L will take care of the other L in the top, and the H on the bottom will take care of the H in the top. What we do to one side, we have to do to the other. So here we have volume divided by length and height is equal to the width. You may see it reversed. That's simply called the reflexive property when you switch the left and right side of the equal sign. All right, our third example is 3x plus 6 equals y, and we're solving that for x. So once again, we're starting, it's already simplified as much as it possibly can. Just make sure that you don't have to distribute or combine like terms or move your variables. If you, only time you're going to move variables is if you have the variable you're solving for is on both sides of the equal sign. That's the only time you really need to move variables. But in this case, we don't have to do anything. We're solving for x. All we have to do is start with addition and subtraction. And the only thing that's being added right now is the 6. So hey, let's get rid of the 6. Subtract it from both sides. Simple. Step 1. And we end up with this. Okay, we know that the y and the -6 are not compatible. They're not like terms. They're just going to be separate, side by side. And now we're going to divide both sides by 3. Whee! Because the 3 is multiplying the x. And so in order to cancel out that multiplication, we have to divide by the same thing. The 3's cancel. That leaves me x equals y minus 6 on top divided by 3. Now, y can't be divided by 3, but 6 can. -6 can be divided by 3. So we're going to separate those real quick and simplify the 6 divided by 3 and just make that -2. Okay? Minus 2. So y divided by 3 minus 2 is our final answer. All right, fourth example is x divided by 3 plus 6y equals 2, and we're solving for x in this particular situation. So once again, we're starting with whatever can be added and subtracted. We're starting the farthest away from x. Okay? Added and subtracted. Right now, the x is being increased by 6y. So we want to decrease it by 6y on both sides. So subtract 6y. Cancel, cancel. And now the x, the only thing that's happening to x is it's being divided by 3. So what's the opposite of division, class? That's right, multiplication. Therefore, once we do it to the left side, those are going to cancel. But what we do to one side, we have to do to the other, and we have to make sure we multiply everything on the right side by 3. So this is where we're going to use the parentheses to group them together to make sure we multiply both terms by 3. 3's cancel, leaving x alone. And now on the right side, we must multiply 3 times 2. That's going to give us 6. Then 3 times -6y. That's going to give us -18y. And that is our correct answer. However, if you're on a multiple choice test, it may show the answer like this. It is the same thing. We just reversed the order in which we wrote them. So -18y plus 6 is the same as 6 minus 18y. All right, last example we have here, pretty simple again. Ax plus b equals y, and we're simply solving for x. So once again, you guessed it, we're subtracting first. We're subtracting b. Okay, we're just doing the opposite of addition, which is subtraction. We always have to do the opposite. If it was minus b, then we would have had to add b just to cancel out the b's. So since we canceled out the b's, we have ax equals y minus b because y and b can't be combined. Remember that. Y minus b is not yb. It's y minus b. And last step is to divide both sides by a, simply because we're multiplying x times a, so we have to go ahead and do that. So the a's canceled on the left, and here we have our answer, y minus b divided by a. On a multiple choice test, there is a chance you might see it like this. That's split up. So now here's a summary We would always identify the variable for which you are solving, the one we want to isolate. Use inverse operations to isolate that variable. Then remember that combining like terms is usually not possible. Usually, not saying they won't throw one at you like that, so be prepared. But adding grouping symbols like parentheses, it might be needed in order to make sure that you do your order of operations perfectly and in order. All right, so here is the homework that I had assigned to you prior to the break. Make sure you get it all the way 100% complete, and make sure you have it by Monday, November the 26th, after Thanksgiving. Guys, have a great Thanksgiving break. I'm just making this tool for you to help you, to remember you, and help to remind you how to do this. All right. God bless. We'll see you later.